Assalamualaikum to everyone. So today our group will present about the motion in the straight line. So before we start our presentation, our group consists 4 group members, which is Intan Kalia Suhana binti Roslan, Nur Ain binti Jafri, Nur Syafina Ilyana binti Karim, and Nur Syifa Izzati binti Indra Syahrizai.
So now we start with introduction. Have you ever wondered how a car knows when to brake, how an athlete calculates their sprint, or how a ball falls to the ground? All of this involve motion in a straight line. By understanding this topic, it helps us to understand how objects move by analyzing their displacement, velocity, acceleration, and time. These concepts are essential in engineering, transportation, sports, and many real-life applications. Let's break down the core ideas of motion, starting with distance and displacement. Distance is simply the total length of the path you actually travel, but displacement is different. It's the straight line distance from where you begin to where you ended, regardless of the path taken. Now let's talk about speed and velocity. Speed is how fast distance changes over time. It's a scalar, so it only has magnitude. Velocity, on the other hand, is how fast displacement changes. It's a vector, so it includes direction. Finally, acceleration is simply the rate at which velocity changes. So if you speed up, slow down, or even just turn on quarter, you are accelerating because your velocity is changing.
Now, let's review the equations of motion used in straight line motion with constant acceleration. The first equation is v equals to u plus a times t. The second equation is s equals to 1 over 2 u plus v times t. The third equation is s equals to u times t plus 1 over 2 times a times t square. Lastly, the fourth equation is v square equals to u square plus 2 times a times s. We need to choose equation that we want to use to find what information that we want by knowing the value given. For this example, a ball is thrown straight upward with an initial velocity of 80 meters per second. We need to find two things: the time it takes to reach its highest point and the maximum height reached. For question A, at the highest point, we know that the final velocity is 0 since it stopped for a while. The information that we have right now is u equals to 80 meter per second, v equals to 0 meter per second, and a is equal to the gravity, which is 9.81 meter per second square. The suitable equation is v equals to u plus at for us to use to find t. By substituting the values, we get 0 equals 18 minus 9.1 t. Solving for t gives us 1.83 seconds. Therefore, the ball takes 1.83 seconds to reach its highest point. For question B, to find maximum height, which is s, we use the equation v square equals u square plus 2as. Insert value of v equals to 0 meter per second, u equals to 18 meter per second, and the a is negative 9.81 meter per second square to find s. Then, we solve the equation and get the maximum height is 16.51 meters.
Next, let's take a look at the practical word problem involving uniform acceleration. As you can see on the slide, we have a cyclist traveling downhill. We are given a few pieces of information. First, he is accelerating at a rate of 1.5 mm per second square. His initial velocity at the top of the hill is 3 meter per second. And we want to find out exactly how far he travels over a time of period of 8 seconds. First, we need to choose the formula. To solve for the total distance, we need a kinematic equation that connects displacement, initial velocity, acceleration, and time. So the perfect tool for this is the formula s equals to ut plus 1 over 2 at square, where s is our displacement, u is the initial velocity, a is acceleration, and t is time. Now let's substitute our known values into the equation. So we plug 3 for U, 8 for T, and 1.5 for A. This gives us 3S equals to 3 times 8 plus 1 over 2 times 1.5 times 8 square. 3 times 8 gives us 24. 8 square is 64 and half of that is 32. Then 32 multiplied by 1.5 gives us 48. Finally, we add those two parts together. 24 plus 48 equal to 72. So our final answer is the cyclist travels a total distance of 72 meters down the hill in those 8 seconds.
In conclusion, motion in a straight line is one of the fundamental concepts in mathematics, physics, and mechanics. By understanding displacement, velocity, acceleration, and time, we can analyze and predict the motion of objects more accurately. This knowledge is important because it helps engineers design safer vehicles, allow athletes to improve their performance, and support the development of modern technology such as transportation systems. Overall, learning this topic not only strengthens our problem-solving skills, but also help us understand how motion works in our daily life.